Our next presenter is Akiho from Department of Medical Engineering, Chiba University, Japan. She graduated from the undergraduate school at Department of Medical Engineering, Chiba University in 2022. Currently, she is a master course student at the department. She studied about tissue characterization of liver fibrosis using echo-embryonic statistics. This work is the collaborative research of Chiba University, Japan, and Changchun University, Taiwan. And the title of her paper is Evolutional Neural Network Classification of Liver Fibrosis States using ultrasonic images colonized by features of echo-embryonic statistics.
Thank you for introduction. Hello everyone, I'm Akiho Isshiki, master's course student at Chiba University, Japan. Today, I would like to talk about our study for CNN-based diagnosis of liver disease using ultrasound imaging. Sorry. In the acute liver disease, the inflammation, necrosis, degeneration process is repeated by the infections owing to hepatitis, virus, alcohol, or fatness. Then fibrous tissues occur and develop around necrotic liver lobule. Eventually, that leads to liver cirrhosis and hepatocellular carcinoma. The progression of liver fibrosis is the most important indicator that determines patient prognosis. The stages of liver fibrosis are classified into 5 stages from F0 in normal liver to F4 in cirrhosis. As the disease progresses, the tissue structure in the liver changes in this way. Pathological examination via liver biopsy is the gold standard for determining the stage of liver fibrosis. However, the biopsy is a highly invasive procedure. Furthermore, there is the possibility of a sampling error. Therefore, we have studied non-invasive and high accuracy diagnosis methods. Ultrasound imaging is frequently used for the observation of liver. However, the spatial resolution and visibility of ultrasound images are not sufficient. Furthermore, there is a speckle pattern in the texture. Changes in tissue structure due to liver fibrosis are also changes in acoustic characterization, such as sound speed, characteristic acoustic impedance. Therefore, the texture on the ultrasound images of liver reflects the characteristic of each stage. Then the progression of liver fibrosis can be estimated from the feature of the texture. In the previous work, we have been analyzed the echo-envelope statistics for quantitative evaluation of liver fibrosis. The shape, skewness, or kurtosis of the probability density function in the ultrasound image are varied by the progression of fibrosis. Therefore, the rate of fibrous tissues and the stiffness of the tissues could be estimated from the features of echo envelope statistics. On the other hand, analysis of ultrasound images using a CNN have been proposed for segmentation, image construction, classification. This slide shows the example of CNN classification of liver fibrosis stages. In the reported publication, the accuracies of the classification of liver fibrosis stages seems to be not sufficient. The full improvement of the CNN classification is currently studied by some researchers. We have proposed the combination of the CNN and echo envelope statistic analysis. In the proposed method, ultrasound images and colors by features of echo envelope statistics. Then the colorized images are classified by the CNN. In this research, we used 80 ultrasound images with hepatitis B and C virus infections acquired at Changgun Memorial Hospital, Linkou, Taiwan. The stages of liver fibrosis and the ratio of fatty deposition were assessed by liver biopsy. Because a sufficient number of cases was not available for F0, the study will be conducted on cases F1 to F4. The other information are shown in this table. In this research, ultrasound images of echo envelopes without log compression were used. In those raw echo data, the effects of focus and gain during transmission and reception were involved. We have eliminated the effects by the normalization using the root of second-order moments. It means the power of echo data are normalized to 1. Then the region of interest is extracted from the segmented liver area. All rods were rotated such that each vertical direction followed the scan line of ultrasound. In the extracted rods, there are some inadequate rods. For example, they involve the areas whose where echo magnitude was smaller or larger blood vessels are appeared. So the rods should be removed via the classification. In our previous study, the multi-ready model is proposed. In this model, the probability density function of echo envelopes in fibrotic liver is divided to 2 Rayleigh distribution associated to the liver parenchyma region and the fibrous tissue region. We can calculate the theoretical third-order moments from the multi-Rayleigh model. The abscissa axis indicates the rate of fibrous tissues. The colors of plots and lines indicate the difference of magnitude between two Rayleigh distributions. We define the range of third-order moments in F1, F2, F3, and F4. Then inadequate rows have been removed like that. To colorize the grayscale ultrasound images, we use first-order moments and fourth-order moments. First-order moments decrease and fourth-order moments increase according to the progression of liver progresses, because high echoes from fibrosis tissue increase in the normalized distribution. At first, all pixel brightness are modulated by the factor calculated from the first order moment in the ROI. This image was assigned to the red color layer. Then the modulated image by the first order moment was assigned green color layer. Finally, original image was assigned to the blue color layer. These images are the colorized images from 32 cases. Basically, colors of roids change from red to green as liver fibrosis progresses. To validate the effect of colorization, liver fibrosis stages were classified through the transfer learning of BGG16. The last fully connected layer was replaced for the four stages classification. Random numbers were assigned to initial weights of the layer. Training layer were convolution layers of 5.2, 5.3, and all fully connected layers. At first, learning rate and dropout were adjusted. Then, 5-fold class validation was performed. Confusion matrix of true and predicted stages are shown in this slide. In the case of original images, the classification accuracy was 38%. In this method, more than 100 rows can be extracted from one ultrasound image. So, the boarding of predicted stages of all rows can be made. By the hard boarding, the classification accuracy was improved to 51%. In the case of colorized images, the classification accuracy of rows was 51%. The classification accuracy by the boarding was improved to 66%. Limited to the classification of F1, F2, and F3, F4, 89% of subjects could be classified. Furthermore, in the case of F1 to others, 94% of subjects could be classified. Let me summarize this presentation. We have studied the quantitative diagnosis of liver fibrosis from ultrasound images. In this research, the combination of the CNN and echo envelope statistic analysis has been proposed. By the colorization of ultrasound images based on their moments, the accuracy of CNN classification could be improved. That's all for my presentation. Thank you so much for your kind attention. I already changed the ultrasound image. So noise. Noise. For example. No.
Thank you. Now we are having a 10-minute conclusion, and we will resume at 3:50. Thank you. Just a time limit, so we have to stop the coffee break. Yeah, we'll begin in 10 minutes. So it's going to be 50.